At 14:37 Universal Time Coordinated yesterday, Amazon Web Services announced a 40% price reduction for their Bedrock Agent runtime API calls, the third such cut in 6 months. This isn't a promotional discount. It's a signal that the infrastructure layer for autonomous agents is entering commodity pricing territory faster than most models predicted. Within 2 hours, Google Cloud responded with their own agent mesh pricing update, and Microsoft's Azure AI Agents platform quietly adjusted their tier structures overnight. The evidence landscape has shifted measurably in the last 96 hours. Hacker News front page analysis shows agent-related infrastructure posts increased 170% week over week. R14 preprints tagged with multi-agent systems jumped from an average of 12 per day to 31 per day. Reuters reported that enterprise procurement data from 3 separate analytics firms shows a 220% quarter-over-quarter increase in cloud spending specifically allocated to agent orchestration platforms. The weighted signal here is strong. Confidence, 78%. Let's walk through the 10 forecasts, bucket by bucket. First, by December 31, 2026, at least 4 of the 5 major cloud providers will offer production-grade agent orchestration APIs with SLA guarantees above 99.5%. Confidence, 72%. The counter-evidence is that current uptime for these services sits between 97.8% and 98.9%, and achieving 5 nines reliability for agentic systems involves solving coordination problems that traditional APIs don't face. Second, enterprise adoption of autonomous agents for customer service will exceed 15% of Fortune 500 companies by Q2 2027. Confidence, 65%. Current adoption sits at approximately 4% based on public disclosures and vendor case studies. The question is deployment velocity versus integration complexity. Third, average token costs for agent workflows will decline by another 50% before January 2027. Confidence, 81%. The pricing war has momentum, and inference optimization is compounding monthly. Fourth, at least 2 major agent orchestration platforms will achieve unicorn valuation by Q3 2026. Confidence, 58%. Venture funding data shows 17 companies in this space raised rounds in May alone, but valuations remain sub $500 million for most. Fifth, regulatory guidance specifically addressing autonomous agent liability will emerge from either the EU or US by Q4 2026. Confidence, 52%. This is essentially a coin flip. The lag between technology deployment and regulatory response is historically long, but the pace of agent adoption might compress that timeline. Sixth, market consolidation begins, with at least one major acquisition of an agent platform by a cloud provider before September 2026. Confidence, 69%. The strategic logic is clear, and cash reserves are high. Seventh, GitHub repositories related to agent frameworks will grow by 300% year-over-year by December 2026. Confidence, 74%. Current growth rate is 180% annualized, and developer interest is accelerating. Eighth, infrastructure costs for running production agent systems will drop below human labor costs for Tier 1 customer service roles in at least 3 countries by Q1 2027. Confidence, 61%. This is the economic tipping point, but it depends on both cost reduction and capability improvement. Ninth, at least one major security incident involving autonomous agent behavior will make headlines by August 2026. Confidence, 71%. As deployment scales, the attack surface expands proportionally. 10th, the split between open source and proprietary agent frameworks will reach 60-40 in favor of open source by December 2026, measured by deployment volume. Confidence, 55%. Current split is roughly 50-50, and momentum could go either way. Last episode, we predicted a 68% chance that agent API pricing would decline by 25% within 3 months. Actual decline was 40%. Our model underestimated competitive pressure. We also forecast 70% confidence that enterprise adoption would remain below 5% through Q2 2026. Current data suggests 4.2%, so that held. Our calibration is improving on pricing dynamics but still needs work on adoption curve modeling. One concrete adjustment: we're adding procurement signal tracking as a primary data source. Enterprise spending patterns lead deployment by 60 to 90 days, giving us better early warning. But here's what we can't yet model well: at what threshold does infrastructure abundance itself become the constraint on agent capabilities rather than the enabler, and how do we forecast the moment when the bottleneck shifts from compute to coordination?